Physics chapter 19, question number 5 and 6. Question number 5. Identify the features of the motion of the trolley in figure 19.3 on page 287 that satisfy the three requirements for SHM. So let's go to figure 19.3. So now you have this trolley, right? So what are the requirements for the simple harmonic motion? There has to be a mass. What is the mass? So we have the mass, the trolley, right? So this trolley is going to be the mass, obviously, right? This trolley is going to be the mass, right? Then what is the other point that we need? The central position or the equilibrium position. So now at this, in this, as the diagram shows, it is in equilibrium position, right in the middle, it is equilibrium. When you pull it to this side, it will come to this position and then go back to this position, passing the equilibrium point or the central point, and it goes back and forth. So that is what that is another requirement for centripetal position. That is another requirement for simple harmonic motion, rather. Then what is the other one? The resultant or the restoring force, right? So restoring force is provided now when it is pulled. When it is pulled to this direction, when from here it is pulled to this direction, there is a resultant force. So that is the resultant restoring force which will act towards the center, right? When it passes this point, it will act. When it passes the middle point, it will act towards the center from this side. So that is the force that is there. So those are the three requirements for this simple harmonic motion for this particular system. I hope you understood. Now let's move to question number 6. Explain why the motion of someone jumping up and down on a trampoline is not simple harmonic motion, right? Their feet lose contact with the trampoline during each bounce. So what you need to understand is, now if this is a trampoline, if there is a man jumping up and down, he will come here. This will actually go a little bit, this will stretch a little, and that will push him upwards, right? Now there is a problem. What is the problem here? Now when this person is, in contact with this, when he is pushing it downwards, his legs are pushing it downwards, what happens is the restoring force is given by this trampoline. But when he goes up into the air, when his legs are up in the air, the restoring force is only his weight, right? That is the restoring force which is constant, right? When he is going upwards, it is not the weight that provides the restoring force. It is the tension that is created by this trampoline, right? So that is the reason why it cannot be considered as the simple harmonic motion. So your answer should contain these details. The restoring force is not proportional to the distance from the equilibrium point, right? So that means he can go really high, right? So let me delete this and draw it again, then it would make more sense to you. Now comparatively, now if this is the trampoline, this person can go this much high, but at the same time this would only stretch only about this much, right? It would not stretch the same distance, right? So this is actually not proportional, so it has to be proportional. So that is one of the factors, right? The force is not proportional to the distance from the equilibrium point. Then the restoring force when he is not in contact with the with the uh, with the trampoline is only equal to the person's weight, and that is constant. So those points need to be there. I hope you understood. If you did not, please ask me questions. Yeah.